Day 9. Day 9, smoke basin. These caves seem to be lava tubes. What is a lava tube? The cave formed by lava. That's cool. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, ooh, we've got a flow problem. You might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Okay, so it's like a trough. Most locations have 4 adjacent locations. Locations on the edge or corner of the map are 3 or 2, respectively. Okay, so we need a neighbor function. And then a trough is basically something which is strictly lower than all of its neighbors. Strictly lower, not lower or equal to. Yeah. So therefore, the risk level of a low point is 1 plus its height. Okay. That's alright to start with. So to start with, I guess we just want to store the grid. Or should we store them as ints because we actually care about their values? Alright, just take a quick peek at this grid. Yeah, looks about right. Okay. And then we want... Okay, so we can say height equals length of grid, width equals length grid 0. So let's define get neighbors. So given an I and j, we want to return all the neighbors. So it's going to be minus 1, 0, 1, 0, 0, minus 1, 0, 1. If so, it's going to be 0 is less than or equal to neighbor I is less than height, and 0 is less than or equal to neighbor j is less than width. And this is a valid neighbor, so yield neighbor I, neighbor j. Okay, that's get neighbors. So the processes go for I in range height, for j in range width. If all, so we want to check if the grid a say h is the value that's at grid ij. So if all the neighbor values are strictly less than h for neighbor I, neighbor j in get neighbors of I and j. So even if it's at the corner, there'll only be 2 values, but if all of them are less than all valid neighbors, oh no, it's the other way around. All valid neighbors are greater than h, then that means ij is a trough. What do we do with that? We add 1 to it. We add up all the risk levels, and the risk level is 1 plus the height. So result 1 equals 0. Result 1 plus equals, so it'll be h plus 1. Print result 1. 535. Correct. Next, you need to find the largest basins so you know what areas are most important to avoid. Basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin, and all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. So this is basically flood fill. We take the low points. From each low point, we do flood fill to find everything that would flow into that basin. And they've said exactly that there can be exactly 1. So you can't have it go up to 5 and then go down to some other trough. It seems that it always only goes up to 9 at most. 9 is like the ridge that separates all the basins. Wait. Doesn't that basically mean that so basically the nines form a border around all the basins, that's it. We still need to use flood fill. Even with that knowledge, we still need to use flood fill because we don't know. Just by looking at the border, we can't identify easily how many regions there are. We need to work out how they connect up and everything. All right. Find the 3 largest basins and multiply their sizes together. Okay. So we just want a list. We want a list of all the basins, and then we can work that out. So okay, this is flood fill, just straightforward. So when we found a trough, that basically identifies a basin. But we want to find how many elements are in that basin. So at this point, I and J is a trough. Right, let's do. So we're gonna have to write a just like a basic DFS. All right, so start from this J. We put this on the Q. We don't care about distances. Put that, but we have a visited set as well. While Q, so we just take stuff off the Q. Q pop. And then we do for neighbor I, neighbor J in. Also visited will be a set. Neighbor I, neighbor J in get neighbors. So first we need to make sure it's not 9. So if grid I J is 9, skip that one, that's not part of a basin. Otherwise, if this was visited before, then it was already on the queue at some point. So continue. Otherwise, we pop it on the queue. Should really just say neighbor equals that. Put it on the queue. Mark it as visited. Then what? Once we've done all of that, it's just the size of visited. That's all we care about. This is basically telling us get basin size for a given trough. It works on any element in the basin. All right. Basin sizes is just a list. All right, now. So we found a trough. We just want to do basin sizes dot append get basin size neighbor I neighbor j. No, I for ij. And then basin sizes dot sort. Reversed. So we start with the biggest. And then we want to print basin sizes 0 times basin sizes 1 times basin sizes 2. Is that what they wanted? Multiply the 3 biggest. Okay. Correct. Okay. That was a nice flood fill warm-up. Nothing particularly difficult, just write the most basic DFS. You don't need to measure distances. You don't need to keep track of the actual set of elements, or at the end of the day, you just want to return the size of the set. So you just use a basic set to keep track of what you visited, and yeah, that's the most fundamental. The only complexity is that you had to do it more than once. But that's about it. And you had to recognize that the 9s form the border, which was pretty much spelled out in the description, but that was the first search problem of this year. Surprising, because last year's actual live competition, we had a lot of BFS DFS, a lot of those. It was full of flood fill problems. Some of them were kind of repeats of past ones, just with different blurb, but yeah, we had a lot of searching, which I mean is fine. It's a very important algorithm, and it's one of the most practical as well for doing real things. I mean, this is exactly the kind of algorithm you'd use to find real basins and real contour maps of real life locations. I mean, it all comes down to this. You just have more granularity of the points, probably, but So we've done day 9. I think we'll stop there. Yep, that's about a third of the way through. Looks like 19 might be a tricky one. Got a bunch of people who've done this. Miss Smabu K, I know, is I think he's done every year now. Captain Coda. I haven't heard much from Captain Coda lately. I don't think he's been streaming much. He might be doing another game jam at some point, like he did last year. Alright, well, I don't really want to do 10 right now, so... Oh, Smap UK, speak of the devil. This is the only year I have 50 stars on, though. Just got here. Oh, welcome in. Yeah, I've just... This is the last year I need to... Oh, it's the only year you have 50 stars on. Do you think it's an easy year, then? So far, it seems quite easy. Yeah, this is the last one on my list. Until I get the much coveted 500 star. Oh, I was gonna look at Captain Coda's leaderboard as well. I see that Captain Coda has done part 1 of day 25. I don't know why. Did he accidentally pick the wrong year at some point when he was doing it? Or maybe he just for some reason wanted to do that specific problem. It's the only year I persevered through the types of problem I hate. Did you do this one live? I think the first one I did live was like 2019, and then I left a gap, and then I came back in 2022, I think. So yeah, I'm going back and finishing them off. Yeah, 2019. Was this the first one I did? Yeah, I think I did this one live. No, I didn't do this one live. I did this one just last year. I was archived. 2020 was the one I did live. The first one I did. All right. Well, I don't know if anyone really streams Advent Code these days because it's mid-year, so it's unlikely. Yeah. All right, that's it for today. Might do a bit tomorrow, probably a bit earlier. That might mean it's like the middle of the night for a lot of people in America or even Europe, but it's more of an afternoon thing for me to do. All right, thanks for watching. See you next time.